Hello children, I welcome you all to this session in which we are going to see coordinate geometry exercise 7.2 question number 6 and 10. First let's start with question number 6. Read the question. 4 vertices are given. All these 4 vertices belongs to a parallelogram. Take it in order. Now we want to find out the missing value x and y. Where x is missing, x is the abscissor of the third vertex and y is the ordinate of the second vertex. Now we are going to find out that. This exercise I told you in the beginning itself. Here in this exercise we'll be using section formula for internal division and external division, midpoint formula and centroid formula. So here in this particular sum we are using midpoint formula to find out the missing value y and x. What are all these vertices? All these vertices are vertices of a parallelogram. What we know about a parallelogram? A parallelogram is a four-sided linear closed 2D shape. And what we know about the diagonals of the parallelogram? Diagonals of the parallelogram bisect each other. So I have drawn a parallelogram and I took the vertices of the parallelogram in order A, B, C, D, and then I have drawn the diagonals. BD is the first diagonal and AC the second diagonal. Both the diagonals meet at H. Both the diagonals are not of same length, but the midpoint of the diagonal BD is same as the midpoint of AC. The meeting point of both the diagonals is the midpoint of the diagonals. So what is the midpoint formula? Midpoint formula is x1 plus x2 by 2, comma y1 plus y2 by 2. Here we found out the vertex H is the midpoint of BD as well as AC. That is what I written here. Midpoint of AC and BD are same. First let me find out the midpoint of AC. For AC, I took the coordinates of A 1, 2 and the coordinates of C x, 6. Now I am applying midpoint formula here. x2 that is x plus 1 by 2, comma y1 plus y2 by 2 that is 2 plus 6 by 2. I found the midpoint of AC. What is the midpoint of AC? 1 plus x by 2, comma 8 by 2 which is 4. Then I am finding the midpoint of BD. For that I took the coordinates of B 4, y and the coordinates of D 3, 5, x1, y1, x2, y2. Now midpoint of BD is 4 plus 3 by 2 and y plus 5 by 2. Now by the condition here, actually the condition is not given in the question, with the clue given we found out the condition that the diagonals of a parallelogram bisect each other. So the midpoint of both the diagonals are same. Then let us equate what is the midpoint of EAC. This is the value of midpoint of EAC. Equate it with the midpoint of BD. So 1 plus x by 2, 2 plus 6 by 2 is equal to 4 plus 3 by 2, y plus 5 by 2. As usual, equate abscissors and abscissa, ordinate and ordinate. So 1 plus x by 2 equal to 4 plus 3 by 2. 2 will get cancelled. 1 plus x is equal to 7. So x is 6. And when I am equating the ordinates, I am getting 2 plus 6 by 2 is equal to 5 plus y by 2. So 2 as usual it gets cancelled. 8 is equal to 5 plus y. So the value of y is equal to 3. Children, what we have learnt in question number 6? 4 vertices of a parallelogram is given. That's all. Out of that 4 vertices, one abscissa and ordinate is missing. We need to find out that. This question belongs to exercise 7.2. So either we need to use section formula or midpoint or centroid. Since we know that the diagonals of this parallelogram bisect each other, here we are using the midpoint formula. So the midpoint of the diagonal BD is same as the midpoint of the diagonal AC. First we found out midpoint of BD using the formula, midpoint formula, as well as AC. Then we were equating both the values we got for AC and BD. When we are equating the coordinates, we are equating abscissa with abscissa and ordinate with ordinate, and we found out the missing value of x and y. X is 6 and y is 3. Let's see the next sum, that is the area of a rhombus. Find the area of a rhombus if its vertices. Rhombus is also a linear closed 2D shape. Here all the 4 sides are equal and 4 vertices are given. What do we want to find out? We need to find out the area of the rhombus. Okay, fine. What is the area of a rhombus? Half into the diagonals, d1 into d2. The area of rhombus is half into d1 into d2. So we need to find out the diagonals. We need not to find out the vertices of the diagonals or the meeting point of the diagonals, but we want to find out the length of the diagonals. Then is it possible for us to find out the length using section formula or midpoint or centroid formula? No. So here which formula we are going to use? Yes, we are going to use the diagonal formula, the distance formula. For finding the length of the diagonal, we are going to use the distance formula. Do you remember the distance formula which we have learned in the same chapter, exercise 7.1? Yes, for any 2 points, how we will find out the distance? Square root of x2 minus x1 whole square plus y2 minus y1 the whole square. So a rhombus is given. All 4 vertices of the rhombus is given. We have drawn the diagonal. First diagonal is BD and the second diagonal is EAC. Now let us find out the length of the first diagonal AC. Take the coordinates of A 3, 0, the coordinates of C minus 1, 4. So x1, y1, x2, y2. Then AC is equal to the formula. Substitute all the values in the formula. Calculate. When you have 2 same signs, we'll be adding. So minus 4. Here also 4 square, 16. So that is root 32. If I simplify root 32, I'm getting 4 root 2. Then I'm going to find out the length of the diagonal BD. Take the coordinates of B 4, 5, the coordinates of D minus 2, minus 1. Substitute that in the formula, the same distance formula. Mark x1, y1, x2, y2. Substitute. Diagonal BD length is 6 root 2. Why we found out the diagonals here? Because we need to calculate the area of the rhombus, which can be calculated only if we know the length of the diagonals. So we found the length of the diagonals using the distance formula, both the diagonals. One is 4 root 2, the other one is 6 root 2. So what is area of rhombus? Half into diagonal 1 into diagonal 2. Substitute all the values. Half into 4 root 2 into 6 root 2. 2 and 4 if you cancel, you will get 2. Root 2 into root 2 became 2. 2 into 6 is 12. Therefore, the area of the rhombus is 24. The area of the rhombus is 24 square units. So, what we learned in question number 10? We learned how to calculate area of a rhombus if we are only provided with the vertices of the rhombus and no other value. Only the vertices of the rhombus is given. Using distance formula, we calculated the length of the 2 diagonals of the rhombus. After that, we calculated the area of the rhombus using the formula half into diagonal 1 into diagonal 2. Now mark your homework. Same exercise 7.2. Question number 8, 7 and 9 is your homework. In question number 8, they gave the coordinates A and B. They are asking you to find out the point P which divides the line segment A and B. The condition for the ratio is given as AP is equal to 3 by 7 into AB. What is AB? AB is the complete length of the line segment. Total AB is 7 parts and AP is 3 parts. When I am writing AP by AB, I am getting 3 by 7. AP alone is 3 parts. The complete line segment AB is 7 parts. Then what will be PB? PB is equal to 4 parts. So in what ratio the point P is dividing A and B? The ratio is 3:4. So coordinate of A is given to you. Coordinate of B is also given. Ratio M1 is to M2 is also given as 3:4. Use section formula and find out the coordinates of P. Now in the 7th question they said that A and B are the coordinates of diameter of a circle and O is the center. If O is the center, what is OB? Radius. If O is the center of the circle, then what is O and A? That is also radius. If OA and OB is equal, then what will be the ratio here? 1:1. When we have the division ratio as 1:1, then what this O is the midpoint. Then which formula we will be using here? Use midpoint formula. So the coordinates of O is given, that is the center. The coordinates of B is given. Use midpoint formula and find out the coordinates of A. Then question number 9. There is a line segment with starting point A whose coordinate is given as -2, 2 and ending point B whose coordinate is given as 2, 8. This particular line segment is divided into 4 equal parts, they said. 4 equal parts. Then how many point of intersections will be there? 3. P, Q and R. We need to find out the coordinates of this P, Q and R. Ratio is not given. So we are going to find out what is the ratio for each particular point. So how many parts are there in this particular line segment? 4 parts. This is your first part, this is your second, PQ, third part is QR, and your fourth part is RB. How many parts? 4 parts. Now, if I want to find out the ratio for point P, towards left, how many parts are there? 1. And towards right for P, how many parts are there? 1, 2, 3. So, the ratio for P is 1:3. The same way come to R. If I want to find out the ratio of R, what I'll do, I'll be counting how many parts are there towards R in the left side. 1, 2, 3. So 3. Towards right it is 1. So the ratio of R is 3:1. Come to Q. For Q in the left side 2 parts, in the right side 2 parts. And it is mentioned in the question that all 4 parts are equal. So the ratio of Q is 2:2, which can be simplified and written as 1:1. Now, in question number 9, you need to find out the coordinates of P, Q and R provided with the coordinates of A is -2, 2 and the coordinates of B is 2, 8. We found out the ratio of all 3 points. The first point is 1:3. Second is 1:1, which is the midpoint. So for Q, use midpoint formula, and the ratio of R is 3:1. Thank you, children. That's all. Like say 7.2 is over with this session. Play the videos one more time after 1 or 2 days and go through all the sums, and please be clear with all the concepts. Do the given homeworks. Catch you on the next video. See you.